Voice system activated.
So let's have a look at the solar hydrogen technology kit, rather delightfully named the Hydro Genius. Allow me to be the judge of that. Alrighty, so it's got several components. There's the solar cell, which is providing energy to electrolyze water into hydrogen and oxygen, which then feeds this fuel cell, this hydrogen fuel cell, which generates electricity, in this case to spin this tiny motor.
Vital sign monitoring activated.
Alright. Rather disappointing. Hopefully it'll be spinning by the time I finish babbling. So the solar panel is made of silicon, and the photons of light from this lamp hit the silicon-silicon bonds and then kick an electron out of those bonds into what's known as the conduction band, and that electron is now free and it can run around this circuit. So the electrons are coming in to this electrolysis equipment here, which is filled with distilled water. And so just to recap what's going on there, that's the solar cell. You don't need to know that symbol for IB chemistry. You've got the negative cathode, the positive anode. Now you have water, H2O, in equilibrium with its ions. And so the positive ion is going to go to the negative electrode, electrostatic attraction. The negative ion is going to go all the way to the positive electrode. More electrostatic attraction. So what's going to happen at this negative electrode? Well, it's full of electrons, that's why it's negative. So the hydrogen ion is going to take an electron and it's going to make hydrogen gas. Well, we need to do a little bit more there, don't we? Hydrogen's diatomic. So I'm going to need 2 electrons and 2 hydrogen ions to get all that to work. And the equation of OH minus going to the positive electrode, I can never remember that. But luckily you don't have to, because in the MERI data booklet, if we go down, there it is. Just reverse this equation. The OH minus goes to some oxygen, some water, and a couple of electrons. So that's the electrolysis. Now normally you add a little bit of acid or alkali to get it going, but apparently that will break this electrolyzer. So I didn't do that. Oh, and there's more hydrogen than oxygen. That's good. Moving on to the fuel cell. Well, this fuel cell has what's called a PEM, a proton exchange membrane. The gas is pumped in from the hydrogen and the oxygen sides of the electrolysis, and there we go, electricity is being generated. I can't believe it works. Let's recap how this hydrogen fuel cell functions. So there's the motor up there. And so you've got hydrogen gas coming in. Now the hydrogen gas turns into H+, in fact 2 H+, and electrons are released. They go around the circuit and spin the motor. Now over at this side you've got the oxygen coming in. This proton exchange membrane allows the passage of these protons, and water is the safe byproduct that's leaking, I think, out of this little hole here. So I've got to make water. It's gaseous, there's no dripping. And I've got some H+ ions. I've got some electrons coming around the circuit, so I had to deal with those. And I've got some oxygen as well going in. So H+ electron, it's not a balanced equation, so it looks like I'm going to have to double this. Now I've got the hydrogens fixed. I need 2 electrons to fix the charge, and I only need half of oxygen. I wonder what happens if I touch those electrodes to my tongue.
Automatic medical systems engaged.
Now what should happen if I switch the light off?
Deactivated.
I'm no longer generating oxygen and hydrogen, but there's enough in the system to keep this going. And indeed, that's still spinning. So this can act as a storage battery. It essentially stores sunlight in the form of hydrogen and oxygen. It essentially stores the energy in sunlight and stores it as chemical energy in hydrogen and oxygen that can then be turned into electrical energy to do work. Oh, not much storage capacity on this one though.
Activated.
I've just noticed on here that there is a little light as well. That's spinning really fast, but you can't really tell because of the stroboscopic effect of the camera. So I've got my 60 watt bulb going in. Let's see what kind of brightness we can get coming out. Prepare for the flash.
Deactivated.
Oh. And it's gone out. So perhaps not the most efficient of systems. Let's switch it on again. I wonder what happens if I touch these to my tongue.
Emergency. User death imminent. Electrical damage detected. Administering medical attention.